go with the next problem. The open loop transfer function of a unity feedback system is given by g of s is equal to k divided by s into s plus 6 into s square plus 4s plus 13. Sketch the root locus and find breakaway break-in points. Second, imaginary crossover points. Third, angle of departure or angle of arrival. Fourth, comment on the stability of the system. So here the transfer function is given, open loop transfer function, and there are 4 poles in this open loop transfer function. So we need to sketch the root locus, and of course while sketching the root locus anyway we are calculating all these points, and also finally we are concluding it. Therefore we will sketch the root locus, there in between we will get all these points. Now we know the steps. Step 1 is locating poles and zeros. How many poles are there? 4 poles. So P is equal to 4. There are no zeros, Z is equal to 0. And what are the poles locations? We have S is equal to 0, minus 6, plus 2, plus J3, plus 2, minus J3. So these are the 4 poles available. Now in this S plane you locate 4 poles. So one pole at origin, one pole at minus 6, and one pole at minus 2 plus J3, the other one is minus 2 minus J3. Step 2 is identifying the root locus area. So we have already poles, one pole is at origin, one pole is at S is equal to minus 6, and here another pole is minus 2 plus J3, another pole is minus 2 minus J3. So now we need to identify the area, and it is very clear from these poles locations on real axis. From S is equal to 0 to S is equal to minus 6 we will have root locus area, and minus 6 to minus infinity we do not have root locus area, and of course from plus infinity to 0 also we do not have any root locus area. Only this portion 0 to minus 6 will have root locus area. So next is we need to take centroid and as well as the asymptotic information. So centroid you can find out sigma poles minus sigma zeros. 0 we have minus 6 and minus 2 plus J2 and minus 2 minus J3, minus 2 minus J3 divided by we have 4 P minus Z. So this gives us minus 2.5. So in S plane I can locate minus 2.5 and that will be the centroid. Now there are 4 angles because we have 4 asymptotes, and we can write here plus or minus 45, plus or minus 225, or 4 different angles 45, 135, minus and minus 225 and minus 315. So with these 4 angles from centroid I can draw asymptotes. Therefore one will be the 45 degrees A1 and A2, A3 and A4. Therefore there are 4 asymptotes from centroid. Next we need to calculate in step 4 we need to calculate breakpoints. So when you are calculating breakpoints, let us take characteristic equation 1 plus GH is equal to 0, that is 1 plus K by S into S plus 6 into S square plus 4S plus 13. And if you write K is equal to f of S function, then you will be getting it as K is equal to minus S power 4 plus 10S cube plus 37S square plus 78S. Then dk by ds is equal to 0. When you do that dk by ds is equal to 0, then you will be getting it as 4s cube and 30s square plus 74s plus 78 is equal to 0, and corresponding 3 roots are s is equal to minus 4.2 comma minus 1.6 plus or minus j 1.38. So there are 3 roots of dk by ds is equal to 0, and out of 3 roots we need to check whether all are valid or any one is valid or all are invalid. We need to check it. First we will take the real pole. The real pole is at minus 4.2. So this minus 4.2 we need to locate in the S plane. We know that from 0 to minus 6 we have root locus area. Therefore minus 4.2 fit into the root locus area. Therefore minus 4.2 is the one of the breakpoint, valid breakpoint. Coming to these two, you can take one complex pole and you can substitute in k is equal to f of s function. Then if you substitute, it is very clear you will be getting a complex value, which means these two are not valid. Therefore, those two are invalid breakpoint. Out of 3 roots of dk by ds is equal to 0, 1 is valid, other 2 are invalid. Next, we need to get imaginary crossover point. So in imaginary crossover point, check the possibility. And of course, here 4 asymptotes, 2 asymptotes are crossing the imaginary. Therefore, your root locus will also cross the imaginary. So write the characteristic equation 1 plus gh is equal to 0. Then you will be getting the equation as s power 4 plus 10 s cube plus 37 s square plus 78 s plus k is equal to 0. So you just form the row array, and the highest degree is 4 here. S power 4, S cube, S square, S power 1, S power 0. And look at the elements entries 1, 10, 37 and 78k, and of course this is 0. Then I can write S square, 370 minus 78 divided by 10. So this gives us 29.2, and this is directly we can copy from there, that is k. Similarly, I can write S power 1 row, and this is going to be 29.2 into 78 minus you have 10k divided by 29.2, and this is of course 0. And what will be the last row? We can directly take that k and we can place here, that will be carry forward here. Now if you want to make one row with all elements 0, generally we look at odd terms of s power odd term, that means s power 1 or s cube or s power 5. Now let us start with the s power 1. So this element is equal to 0, and for that element when you equate 0, if you get k value positive and real, so with that k value I can make this entire row with all 0 elements, then I can form the auxiliary equation. Then when you substitute this is equal to, equate this equal to 0, and you will be getting the k value as 227.7. So when k is equal to 227.7 and this s power 1 row having all 0 elements. So you just look at the coefficient of the just before row, so which are 29.2 s square plus k. K we know already 227.7. When you substitute and equate it to 0, and you will be getting the s value is equal plus or minus j 2.8. So this is nothing but my imaginary crossover point. S plane is available, just locate imaginary crossover points there and